Hello and welcome to 3.7, Derivatives of Logarithmic Functions. So in this section we're going to be looking at using implicit differentiation to find derivatives of logarithmic functions. In particular, we're going to be looking at the natural log function, ln x. So it's important to remember the forms for taking the derivative. Derivative of log base a of x and derivative of ln x. So natural log of x. So now let's take a look at how we would differentiate a natural log function where the argument is also a function. So here we have to use chain rule. So the process would be we would take 1 over our argument. So we would have 1 over x cubed plus 1 times the derivative of our argument. And the derivative of x cubed plus 1 would be 3x squared. Put it all together and we would have 3x squared over x cubed plus 1. And that would be our final answer. So what does that tell us? We're going to be taking, when we do derivative of natural log of u, 1 over u times du dx. And if you're using like a f of x, g of x notation, we would have g prime of x over g of x. So let's do example 2. Find derivative with respect to x of natural log of sine x. So this means we would have 1 over sine x times the derivative of sine x, which will be cosine x. So that gives us cosine x over sine x, which we could just rewrite as cotangent of x. Let's take a look at our next example. So here we have f of x equals the square root of the natural log of x. Let's rewrite the square root as the power. So this would be f of x equals ln x to the 1/2 power. So that means we would take and use our power rule, outer function first. So 1/2 times ln x, subtract 1, and now take the derivative of ln x. So derivative of ln x would be 1 over x. So let's simplify this. What would this come out to be? So we would have the ln x goes to the bottom. We already have a 2 on the bottom. We have an x on the bottom. And then the ln x would be in a square root. So square root of ln x. So derivative would be 1 over 2x times the square root of natural log x. Differentiate f of x equals log base 10 of 2 plus sine x. So to differentiate this function, we would look back at our formula, the first formula we have up here. So log base a of x its derivative would be 1 over the x, the argument, times ln of the base. Okay, so for us, we would have 1 over the argument times ln of the base. And then we would have to take the derivative of the argument. Okay, so derivative of 2 plus sine x would be, derivative of 2 is 0, derivative of sine x is cosine x. Okay, and then just putting it together, we would have the cosine x on top, and then 2 plus sine x times natural log of 10 on the bottom. And that would be the final answer. Let's take a look at this one. Find the derivative with respect to x of natural log of x plus 1 over the square root of x minus 2. Okay, so that means we would have 1 over the argument here. So 1 over x plus 1 over square root x minus 2. And then we're going to multiply by the derivative of this function. Okay, so the derivative of this would be quotient rule. So we would have square root of x minus 2 times the derivative of the top, which is just 1, minus top times the derivative of the bottom. Now derivative of square root of x minus 2 would be 1/2 times x minus 2 to the negative 1/2. And then this would be all over the square root of x minus 2 squared. Okay, so now simplifying on the left, 1 over this fraction is going to flip this around. So it'll be the reciprocal, square root x minus 2 over x plus 1. Okay, inside here we have square root of x minus 2 minus now here we have x plus 1 times 1/2 and then this x minus 2 to the negative 1/2, that'll be square root of x minus 2 and then the denominator, the square root squared, that's just x minus 2. Okay, next, if we distribute this outside term to our expression inside, we'll see that the square root of x minus 2 times square root of x minus 2, that would just be x minus 2. And then the square root of x minus 2 on top with the square root of x minus 2 on the bottom, those would cancel. So we would just have the 1/2 x plus 1. And then the denominator would have the x plus 1 multiply with the x minus 2. Okay, so let's simplify this then. The top we have x minus 2. Now this minus a half we could distribute, so that would be minus a half x and then minus a half. Okay, so x minus a half x is a half x. Negative 2 minus a half would be negative 2.5, so negative 5 halves. And then what we could do to avoid this fractions with a fraction, here we're going to multiply top and bottom by 2. Right? Multiply the top by 2, the bottom by 2. So that'll give us x minus 5 over 2 times x plus 1 times x minus 2. And then that'll be our final answer. Okay, so be careful of problems like these. You see there's multiple steps. Don't just try to take any shortcuts. Make sure to show all your steps. Okay, especially with problems like these. You want to try to simplify as much as possible while showing all the work. Okay, let's find the derivative. If f of x equals natural log of absolute value of x, now remember, for the natural log of absolute value of x, this means that we could have ln x, or we could have ln of negative x, depending on if x is positive, we have just x, and if x is negative, we have negative x. Okay, so this is how we would define our function. And so if that's the case, we would then declare the derivative. We could take the derivative of each one. For ln x, that would be 1 over x. And then for ln of negative x, that would be 1 over negative x times the derivative of negative x, which would be negative 1. Okay, which would, we would have a negative 1 over a negative x, which would just become 1 over x. Okay, so therefore we could say that since these two are the same, okay, and remember this is when x is greater than 0, and this is when x is less than 0. Since those two are in agreement, then we could just say that the derivative would just be 1 over x. Okay, so that brings us to our definition of natural log of absolute value of x, and that's equal to 1 over x. Okay, logarithmic differentiation. So these problems you could do is use your properties of logs in order to help you to take the derivative. Okay, so what we typically do here is we take log of both sides, and then we use the properties of logs to break down these fractions a little bit further. Okay, and then we use implicit differentiation in order to do that. Okay, so we take ln of both sides here. Okay, so we would do ln of y would equal ln of x to the 3/4 times the square root of x squared plus 1 all over 3x plus 2 to the 5th. So now using our properties of log, okay, now that we took the ln, and let's go a little bit further, especially on the right side, we want to expand this out as much as possible. Okay, so the left side is ln y. And then the right side we would have is ln of x, ln of x squared, square root x squared plus 1, ln of 3x plus 2 to the 5th. Okay, so now when we take the ln of x to the 3/4, we could move the 3/4 in front as one of our properties of the log. So we would have 3/4 ln x. Now the square root, it would act as a 1/2 exponent, so we could bring that in front. So 1/2 ln of x squared plus 1. And then minus, because we have a denominator here, and then the 5 would come in front, ln of 3x plus 2. Okay, so once you're able to expand it all the way out, now you could take the derivative of this step in all blue that I wrote here. Okay, so we take the derivative of ln y. Now implicitly this would be 1 over y times dy dx. And now take the derivative of each term. Okay, so here we would have 3/4 times the derivative of ln x, which will be 1 over x. And then here this would be 1/2 derivative of ln x squared plus 1 would be 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x, minus 5 times 1 over 3x plus 2 times the derivative of 3x plus 2, which is 3. Okay, so let's simplify a little further here. We have 1 over y times dy dx. This will be 3 over 4x plus now here the 2 and the 2 of the 1/2, these would cancel. So we have x over x squared plus 1 minus 3 times 5, that's 15, over 3x plus 2 . Okay, next step, we're going to multiply both sides by y to get the dy dx alone. Okay, so if we multiply both sides by y, that means we would be left with dy dx. And now we're not going to leave that y there. We're going to replace y with what it was equal to. Okay, so let's look back in the beginning. Y was equal to our original problem. Okay, so y is equal to this. So we're going to replace y with our function from the problem. Okay, so that would be x to the 3/4 times the square root of x squared plus 1 over 3x plus 2 to the fifth times 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And that would be it. That would be the final answer. Okay, for these types of problems, when you're taking the logarithmic differentiation, this is okay. You don't have to go all out to get a common denominator, and that would just be a little too much. Okay, so this is okay. But you definitely want to get the dy dx alone. You multiply by y, and then you replace y with the original function. Okay, so you don't go that far. Okay, so just general steps in logarithmic differentiation. We take the natural log of both sides. Okay, and we use our logs properties, our laws of logs, to simplify. Differentiate implicitly with respect to x, and then solve the resulting equation for y prime or dy dx, whichever you happen to use in the problem. Okay, so just some general properties again with exponents and bases. One thing we should note as we're doing these, that you want to distinguish between the power rule, x to the n, and the rule for differentiating exponential functions, a to the x. Okay, so you have x to the n, you have a variable to a constant with the power rule. With exponential functions, you have a constant to a variable. Okay, so there's the switch off. Okay, and these are just some general properties you guys can look at. Let's do another problem. Differentiate y equals x to the square root of x power. X to the square root of x power. Okay, so what we'll do here is we'll use logarithmic differentiation. Okay, so we'll do ln of both sides. Okay, so that allows us to write the square root of x in front. We have ln y equals square root of x times ln of x. Okay, so now we could take the derivative of each side. So the derivative of ln y would be 1 over y times dy dx. Okay, and on the right side, this will be a product rule. So we have, this is x to the 1/2, so square root of x, let's do square root of x, times the derivative of ln x. Okay, derivative of ln x is 1 over x, plus ln x times the derivative of square root of x, which will be 1/2 x to the negative 1/2. So we're going to simplify a little further. have square root of x over x plus, this will be ln x over 2 square root of x. So this square root of x over x, that would actually simplify a little further. We could cross out square root of x. Picture this as being x to the 1/2 over x to the 2/2. We would be resulting with 1 over x to the 1/2. So 1 over square root of x. And then to simplify even further there, we can multiply top and bottom of this left fraction by 2. So that means we combine it into one fraction, 2 plus ln x over 2 square root x. Okay, multiply both sides by y. So we have dy dx. And now replace y with what we had in the beginning. Okay, so y is equal to x to the square root x. And then that would be it. That would be our final answer. Okay, and then we just finish with a simple observation of the function 1 over x. Okay, and this is 1 over x. A little variation on it. This will be the function 1 plus x to the 1 over x power. Okay, and the limit as x approaches 0 for this function. Okay, actually it turns out to be a whole there. Okay, but the limit is approaching a special value in math. Okay, it's approaching the natural number e. Okay, the constant e, 2.71828. And then it continues 2818, and then there's some other numbers after that. It's irrational. Okay, and another version of that number, if we change 1 over x to equal n, would be this number, and limit as n approaches infinity of 1 plus 1 over n to the n power. This will be equivalent to e as well. Alright, so that's it for today's lesson. Okay, derivatives involving logarithmic functions. Any questions, just let me know. Email me. Have a good day. Have a good night. We'll see you soon.